Pattern recognition, computational thinking, topic 1. Learning objective. Identify the term pattern recognition. List a range of different patterns within given scenarios. What is pattern recognition? When we decompose a complex problem, we often find patterns among the smaller problems we create. The patterns are similarities or characteristics that some of the problems share. Pattern recognition is one of the 4 cornerstones of computer science. It involves finding the similarities or patterns among small, decomposed problems that can help us solve more complex problems more efficiently. What are patterns? Imagine that we want to draw a series of cats. All cats share common characteristics. Among other things, they all have eyes, tails and fur. They also like to eat fish and make meowing sounds. Because we know that all cats have eyes, tails and fur, we can make a good attempt at drawing a cat simply by including these common characteristics. In computational thinking, these characteristics are known as patterns. Once we know how to describe one cat, we can describe others simply by following this pattern. The only things that are different are the specifics. One cat may have green eyes, a long tall tail, and black fur. Another cat may have yellow eyes, a short tail and striped fur. Why do we need to look for patterns? Finding patterns is extremely important. Patterns make our tasks simpler. Problems are easier to solve when they share patterns because we can use the same problem-solving solution where the pattern exists. The more patterns we can find, the easier and quicker our overall task of problem solving will be. If we want to draw a number of cats, finding a pattern to describe cats in general, for example, they all have eyes, tails and fur, makes this task quicker and easier. We know that all cats follow this pattern, so we don't have to stop each time we start to draw a new cat to work this out. From the patterns we know cats follow, we can quickly draw several cats. What happens when we don't look for patterns? Suppose we hadn't looked for patterns in cats. Each time we wanted to draw a cat, we would have to stop and work out what a cat looked like. This would slow us down. We could still draw our cats and they would look like cats, but each cat would take far longer to draw. This would be very inefficient and a poor way to go about solving the cat drawing task. In addition, if we didn't look for patterns, we might not realize that all cats have eyes, tails and fur. When drawn, our cats might not even look like cats. In this case, because we didn't recognize the pattern, we would be solving the problem incorrectly. Recognizing patterns. To find patterns in problems, we look for things that are same or very similar in each problem. It may turn out that no common characteristics exist among problems, but we should still look. Patterns exist among different problems and within individual problems. We need to look for both. To find patterns among problems, we look for things that are the same or very similar for each problem. For example, decomposing the task of baking a cake would highlight the need for us to know the solutions to a series of smaller problems. For example, what kind of cake we want to bake, what ingredients we need and how much of each, how many people we want to bake the cake for, how long we need to bake the cake for, when we need to add each ingredient, and what equipment we need. Patterns among different problems. Once we know how to bake one particular type of cake, we can see that baking another type of cake is not that different because patterns exist. For example, each cake will need a precise quantity of specific ingredients. Ingredients will get added at specific times. Each cake will bake for a specific period of time. Once we have the patterns identified, we can work on common solutions between the problems. If you have a look at the image on the screen, you can see the example of the patterns. Pattern recognition. Here, it is important to create tasks which require a pattern to be identified. Geometric programming is a natural place to start. Have a look at this picture. What do you think is the pattern? The numbers are a clue. The pattern recognition needs to be recorded in logical words or math words and be precise. A student attaining pattern recognition may be able to work out the programming around a hexagon drawing, a specific pattern leading to a specific program. Pattern recognition. We are now looking for the next step in thinking, and this is a big one. We need to find the general pattern, or, in math speak, the general formula. If we think of it as the development of formula, it is much easier to grasp this step. What do you think the following code will do? FD1 RT90, FD1 RT90, FD1 RT90, FD1 RT90. What shape do you think this code is going to create? Patterns within problems. Patterns may also exist within the smaller problems we have decomposed too. If we look at baking a cake, we can find patterns within the smaller problems too. For example, for each cake, we will need precise quantity of specific ingredients. Each ingredient needs identifying, in other words, naming, and a specific measurement. Once we know how to identify each ingredient and its amount, we can apply that pattern to all ingredients. Again, all that changes is the specifics.